Okay, in this video I want to go a bit over the practical details of setting up the MQTT broker. You probably have read the theory slides on MQTT. I hope if you haven't, please do go back to those slides, and that will provide you a more theoretical overview of the protocol. So what MQTT is a networking protocol for devices, specifically IoT devices, to communicate among each other. This includes also things such as laptops, computers, data centers, your mobile phone, and little sensors that are perhaps in a mountain somewhere in Switzerland or under the desk measuring the temperature, or all kinds of things. It is the dominant protocol these days for connected devices. It is suitable for sensors, sensor applications, perhaps less so suitable for things such as audiovisuals and other applications that need really low latencies. MQTT is more specialized on making sure that the message gets delivered, irrespective of how long it takes to get there. It's very low power because sometimes it's used in very power sensitive applications such as sensors in remote locations, running on solar power, etc. So oftentimes an IoT device basically just switches itself on, sends a measurement of some kind, like for example temperature on top of this mountain in Switzerland, and then switches itself off back again. In order to be able to do that, it needs a mediator, and that mediator is the broker, which is a server somewhere on the internet that receives messages from devices and then publishes and routes those messages to all the subscribers. I think you read already in the theory that MQTT is a pub-sub protocol, so that means that a sensor publishes something like a measurement, like for example temperature or humidity, or light levels, or touch or no touch, and then another device somewhere else will only receive those messages if they subscribe to those messages in the broker. So let's go into how to practically set up a broker. Now we have one broker in MDD set up in our server, but I personally prefer to use this one, shifter.io, mostly because of the visualization that it comes with, because it's really great for working and seeing things happen live. So I'm going to sign in just so that you see what Shifter is like, and I'm going to set up. I am already auto logged in because I have password manager, and I've been here before, but the username and the password are in the slides that I shared with you. Let's all use the same account, and when you log into that account, you will see that there is. If I click here in instances, these are all cloud instances. So these are all servers. These are all brokers somewhere in Switzerland, of all places. It happens that Joel's company is there. Here we have one. This is the one that I've been using for preparing these sessions. But actually, I think it's best if we all, let's say, if each Gen X, Gen Y, and Gen Z, if you all create one server for yourself. So actually, here in instances, I can say deploy. I'm going to create a basic instance, and for the purposes of this demo, I'm going to create the first one, Gen X. All right. It says that the name must be at least 5 characters, so we are 1 character short. I'll make it a dash. So we have Gen X. Please create also Gen Y and Gen Z, and all the students in the couples are in these, in the pairs are in these generations. As I decided to divide you mostly for being able to manage groups during the sprint. You all have one server for yourself. I've picked the basic free service, as you can see, which allows us 1,000 different devices and 5,000 messages per second. So that will be enough for the purposes of this sprint. And this here is the address of the cloud server that we are deploying. And that's it. We just deploy the instance, and as you can see now we have 2. I'll go into the GenX one and I'll set up a connection for, so as you can see the address has changed. It opened the new browser tab and it says please sign in. So it's a separate login for the cloud instance. In my case, I'm already logged in, so all I have to do is just do that. And this is it. This is a clean instance. This was just deployed for our purposes. It runs for free for 6 hours a day, and we can use it for this workshop. The next thing I'm going to do is I'm going to set up a token for a device. Now, the way that devices use the broker is they use a token. A token is like a username and a password, with the slight difference that the device or the, let's say, the user or the end user of that token is not the one that keeps it or validates it. It's the server that does that. I'll explain why that is or what that means in a second. So over here in general settings, I'm going to repeat that because maybe I did it too fast. I'm used to this, but over here you see that there are a bunch of icons, and yeah, this basically hides the widgets and just gives us the full visualization. And here in open settings, this is mostly where we have to configure access for any new devices. So over here, I'm going to create a token. So we do that by clicking here and create a token. And let's give it a name. So please choose a team name, the pair of you, choose a team name like Team Alpha, let's say. And then I'm gonna call this Team Alpha Desktop. All right. Each device will get a different description. This, once you are, you know, like 11 or 10 of you working on the same instance, it will be super useful because any given team is gonna have 2 or 3 tokens. So after a while, it will get confusing. So give it a meaningful name. All right. This is going to be your password. This secret thing is going to be your password. This is also what you have to put in the Arduino code, and anywhere else where you want to connect to this broker, you're going to need this. And here in permission, we leave it as full token, and yeah, that's it. Then it gives us this URL here. We can come back to that a little later. And I'm going to create another token, this one for Team Alpha, and then IoT device. All right, so I have 2 tokens, one for the device and one for the desktop. Now, the reason for tokens to be handled this way is because imagine, as I said, that you have a sensor that is really remote, like I don't know, a weather station somewhere in the mountains in Switzerland. And you are in Amsterdam, you are administering this network of sensors, doing a project for a company that does you know, IoT stuff. And you want to, let's say, one of these sensors gets hacked or it gets damaged or is sending bad data, then you want to be able to revoke the stream that sensor is sending from the broker. So you don't have to hike all the way up to that mountain, fix the sensor, or reinstall whatever the sensor needs. You want to just be able to invalidate that remotely from the broker. So that's the reason for tokens. It's a form of authentication that can be done on the broker. And that's all we need. I'll show you how to use these settings in so the part of your pair that is doing the Arduino, they will also get that. There is a video also on that, on how to change this in the little microcontroller, the HUSA32 that we are using. And yeah, this is it. If you want to revoke a token, I think that's possible. You can just say delete token, and that will forbid access to whatever device was configured with that token. Yeah, I think that's it for a basic setup. I will stop this video and I'll see you in the next one.